Wait, there are operators other than equality? Why does nobody tell me these things? Welcome to this video on querying SQL Server. My name is Kevin Fiesel. I'm the proprietor of Catalyxy Services LLC, a consulting firm which specializes in work all across the data platform space, especially SQL Server. We've looked a little bit at the where clause in prior videos, and to this point, I focused on using equality operators. But it turns out that there are several other options available to us, and in this video, we're going to look at those in turn. Let's start with that humble equality operator, equals. In addition to equals, we have a few inequality operators. Greater than or equal to, less than or equal to. But we also have two ways of describing not equal to. The ANSI standard way is a less than sign followed by a greater than sign. You'll often also see a second way of writing this, an exclamation point followed by an equal sign, which you'll typically see in C-based languages. I do prefer the ANSI standard way because some flavors of SQL don't support the C-style inequality operator. So because there's a cross-platform method which has no practical drawbacks compared to the T-SQL specific method, I'll use the cross-platform technique. We also have is and is not. But don't assume that is the same as the equal sign or that is not is the same as the inequality operator. Is and is not detail with null. Null is a special abomination which tells us we don't actually know what the right answer is. Is null equal to 3? Don't know. Is null not equal to 3? Don't know. Null could be anything. It might even be a boat. The next operator we'll talk about is in. In is a simpler way of saying that we want cases where some column is equal to 1, or is equal to 2, or is equal to 3, or is equal to, well, you get the idea. We include all of the cases in the in operator and move on with life. In is great for relatively small lists, though if you're passing in hundreds or thousands of items, you'll probably see degraded performance or possibly even failure depending on how many inputs you have. Between gives us a range, inclusive on both sides. Between makes a lot of sense for numbers, as we tend to think of numeric ranges as inclusive. If I tell you to give me all the numbers from 3 to 8, it's going to include 3, 4, 5, 6, 7, and 8. So the numbers between 3 and 8 is inclusive. Between is equivalent to writing where x is greater than or equal to 3 and x is less than or equal to 8. When it comes to dates, however, we tend to think in terms of an inclusive start, but an exclusive end. If I tell you to look for invoices between January 1st and February 1st, you'd focus on the month of January. But for SQL Server, if you write the clause with a between operator, it will include those invoices on February 1st itself. We'll see more of this in the demo. Finally, we have exists and not exists. Exists is an example of a subquery, a query inside a query. Exists says, do we have at least one example of this thing I'm asking for in the subquery? I don't need to know how many there are or even bring back results. I just want to know if it's there. By contrast, not exists makes sure that a subquery does not return results. There's no there. So these are the operators we're going to work with. Let's get on with the demo. Here are a couple of queries we wrote in a prior video, retrieving population data by zip code for Chicago and the United States as a whole. Now, let's go one step further and see the distinct years in Chicago and in reference data. For Chicago, we can see that there are 2 years worth of data, 2018 and 2019. Reference data, meanwhile, has dates ranging from 2011 through 2018. Let's mess around a bit with some equality operators. First, we'll try not equal to. We represent inequality with less than and greater than, and I can see how many records there are where the year is not 2018, giving me 59 results. Because we know that the only other year in this dataset is 2019, I can assume that searching where year is greater than 2018 also gives me 59. Now, sometimes we're a little indecisive, a bit wishy-washy, and we just can't decide if we want something greater than 2018 or if we just want 2018. Fortunately, SQL Server can help us out with our indecisiveness with greater than or equal to. There are 118 total results in the table. We can confirm this by checking where the year is less than 2018. We don't get any results back, indicating that, yeah, there's nothing else here for us. But just to make sure I didn't goof on anything, let's check Chicago where year is less than 2019. That's going to capture the 2018 data. And just in case you were curious, less than or equal to is also just as valid as greater than or equal to. By the way, inequality operators, they work on things other than integers. We can perform inequality operations on most data types, including date and time types, numeric types, even strings. Now, one thing to remember about strings is that your collation will matter for things like sort order and equality. The next thing I want to talk about is the between operator. Granted, I'm going to say mostly bad things about the operator. I mean, okay, in fairness, the operator itself is fine. It's our expectations of how the operator should work that are often at fault. When we talk about date ranges, we say things like, give me all the records between January 1st of 2017 and January 1st of 2018. The problem is we typically think of date ranges as inclusive on the inside and exclusive on the outside. But if we run this query, we get 23,139 records because between is including data for both 2017 and 2018. Let's rewrite this query to use one greater than or equal to and one less than. This query returns 11,581 results, which is the correct number for what we as humans would normally expect, data in the year 2017. And by the way, we can use parentheses to break these statements out and ensure we have the correct order of operations, which matters when you have combinations of and or. The next statement is the in operator, which allows us to include a set of inputs. Here, for example, are 2 zip codes in central Ohio. We can see the population changes over time for these 2 zip codes. One thing I want to call out is that you can run into trouble if your in list is too large. This can lead to poor query performance, excessive memory grants, and even sometimes having queries fail, so don't do that. Also, here's a quick warning about null. Null is awful. This is a perfectly normal query without any nulls in it, but it includes a not in, meaning we get all the rows except for these 2 zip codes. We get back 263,896 perfectly normal rows. Now let's see what happens if we sort of accidentally have a null. I mean, it's pretty dumb to do this directly, but we might write a query which happens to generate this result. When I run the query, we end up with 0 results. The next thing I want to talk about is the exists operator. First up, I'm going to show you how many zip codes there are in our US dataset which have corresponding matches in our Chicago dataset. There are 928 total rows here, but we can see that there are 2 results for each year, and that's not quite what I want. Oh, by the way, if you hate this select star here, one thing you can do in Azure Data Studio, sometimes, is put the cursor on the asterisk and strike Control-Enter. That'll correct this awful mistake. Let's switch things around just a little bit and say that we want to get rows in the US Census set as long as there's a corresponding row in the Chicago dataset. By using the exists clause, we can check to see if there's at least one record matching the subquery. I don't care if we have 1 record or 1,000 records, I just need to know that there is one. And when I run this query, I get back the 464 rows that I expect. But what happens if I say, well, select null? Unlike with the in and not in statements, exists doesn't actually care what you choose. As we can see here, null is enough to get the query to return back every row in the reference data table. If I don't want that behavior, the thing is that I need to return no rows, not a row with null. Here's an example where I try returning data with a year less than 2000, something we know won't give us any rows back because the data only ranges from 2018 to 2019. When I run this query, we get no rows back, just as we expected. Not exists works the way you'd expect. If we do not find a row in the subquery which satisfies our condition, go ahead and return a row in the outside query. What this means for performance is that exists can be a nice performance boost when you're checking for the existence of a frequently occurring value in a large table and you have an appropriate index set up. You don't need to find all occurrences of that value, just one. With not exists, however, you need to make sure that their value isn't there, and so you get no performance boost, unfortunately. This last not exists query gives me all the rows which exist in the US dataset, but not in the Chicago dataset, for a total of 263,448 rows. The first time I saw the is operator, I thought it was a really cool way of writing equals, allowing me to get some Babylon 5 vibes in my queries. Sadly, this query generates a syntax error and was probably the real reason Babylon's 1 through 3 blew up. It turns out that the is operator really works for null, so you can check to see if any rows have null for a year. But because this is a sane dataset, all the rows have year values. We can also run the analog of is with is not null, giving us the results of our sane dataset. Something new in SQL Server 2022 is the syntax is distinct from. To motivate this new bit of syntax, let's run this query. We know that all the rows have non-null values, so obviously checking where the year is not equal to null should return all rows, right? Nope. That's because null is unknown, so we don't know whether null is actually equal to anything. It is a little bit of a head scratcher, but it does make logical sense if you noodle it hard enough, and it's part of why I hate null so much. What's nice about is distinct from is that it serves two separate purposes. First, if the left-hand side and the right-hand sides of the query are both non-null, it performs a not equal to operation. If one or the other side is null, we also perform a check to see if both sides are null. Then we trigger a result on is distinct from in one of three cases. We have two non-null values which are different from one another. The left-hand side is null and the right-hand side is not, or the right-hand side is null and the left-hand side is not. In this case, we have 118 results because it includes data from 2018 and 2019. If I try again, I can see that there are 59 rows which match the predicate where year is distinct from 2018. And we still have 118 rows distinct from null because, again, we don't cater to those null types in these here parts. Is not distinct from is the analog, and it returns results as you would expect. We have 58 rows matching the year 2018. And there you have it. These operators let us query our data in a fine-grained manner, and as we saw, we can chain operators together. Of course, operator precedence is a real thing. This chart from Microsoft Learn shows the precedence of operators. So a bitwise not operator acts before anything else, followed by multiplication and division, and so on down the chain. In case you're confused by this, remember that you can use parentheses to override or clarify operator precedence. We'll have links and show notes in the description below. And until we see each other in the next video, take care.